Hello. This video is going to be on the derivative. Now, everyone is familiar, say, with a line, which whose equation is y equals mx plus b, and we all know, hopefully, that m here is the slope of that line, meaning the inclination, the amount of steepness of the line. Now, what happens if you want to find out the slope of a more complicated function than y equals mx plus b? Or for that matter, how do you find the slope of y equals mx plus b? I just said it was m, but what's the expression for m? Well, m is equal to the rise over the run. Now, that isn't a precise mathematical definition. What the rise is the change in height. In this case, it would be the change in the y-coordinate. So you would pick 2 points, and the difference between the first and second point is your rise, your change in y. Likewise, for the run, that's the change in x. Again, second point minus the first. So all you have to do is pick any 2 points on this line, apply this formula, and you have the slope. So what would you do with a graph that looked like this? I'll draw the whole 4 quadrants this time. Now, I hope you recognize this as a parabola, the most basic of which is represented by this equation. Now, obviously, this parabola has a slope. And in fact, if you look at it carefully, it has many different slopes. The slope near the bottom is not nearly the same as the slope higher up on the side. This slope is quite steep, whereas this slope is perfectly flat. The slope changes as the equation changes. You can also see in our equation here that there is no m. There is no cheat number that automatically gives you the slope. It turns out that calculus is necessary to calculate the slope of this graph. If you were to apply, say, the slope between this point and that point, if you were to apply our little equation above, you would get a high number, say 4. If you were to apply the same equation down here at this point and this point, you would get 0. Sample points for you to work at home. You can try these values here. Try x equals -1, which would give y equals 1. And for your second point, you can try x equals +1, which will give y equals 1. And pick any other point you want. Try a couple of these out and verify for yourself that the slope changes at different points. So how do you find the slope at every point? And what would it look like? Well, there's not going to be a single number, 7, 17, or 12, that gives you the equation, that gives you the slope at every point. What you will actually need is an equation that gives you the slope at every point. See here. Now let me redraw my quadratic here. I'll just draw the first quadrant of it. Yep. Y equals x squared. You will need the derivative. Well, where should we go searching for this magic formula? Okay, let's go back to the old formula. Let's try it there. I'm going to say a y2 minus a y1 over x2 minus x1. But be a little more specific here. What is y equal to? Well, y is equal to x squared. Y is also a function of x. So y2 is a function of x2. y1 is a function of x1 over that same x2 minus x1. Now, the two inventors of calculus, Leibniz and Newton, geez, can't believe that one gave me a little bit of trouble. They decided that the slope became more and more accurate the closer the 2 points you pick. Now, let's say, look back at our graph over here. Let's say I picked that point there, and this point here, and look at the slope. Now, can you see here the gap between the red line and the black line, which I'll mark in green? Look again at another graph if I pick 2 points that are much closer together. We have less of a space. Imagine if you could get 2 points so close together that they are the same point within an infinitesimal distance of each other. That is to say, if you look at our equation over here, instead of x2 minus x1, let's just say we had some value really small. We would be getting closer to the proper form. Now, what does this look like? Really small is not a precise mathematical definition. But now, we will see why you sweated so hard over limits in the last module. Take the limit as h goes to 0. That is to say, as h gets really small. And this is your equation for slope, which you can use on any function. Okay, well, let's try it out. Let's take this y equals x squared business and give it a shot. Now I'm going to do one more thing to it, one more thing. x2 and x1, there's no reason to use them both. We know that the distance between them is very small. So x2 is in fact equal to x1 plus something really small. Well, we've already defined really small as h. So the whole formula will look like this. Now that x1 plus h looks a little trickery there, but just remember that it's just x2. And now we can actually work a problem, which we'll need to do in the next video. All right, thank you.